reviews. We're just going to go over the polynomial review questions here. Tried these out yet. Stop this video, try them out, and then come back to this. You just look at the PDF too if you just want to check your answers. So let's get on this. So here they just want us to sketch this graph, and they want to, I don't know, the easiest way to do it is just pull out your calculator, pull up Desmos here. Like, I'm not stopping you from using Desmos. It's a really good tool to use, much easier to use than this. Even some high schools and universities just allow you to use Desmos right away. Like, there's no point to try to limit yourself to these kind of graphing calculators. Plus, most universities nowadays don't allow graphing calculators. They use just scientific calculators. So just use Desmos if you can. So let me just plug this into the graphing calculator here. Okay. So I want to get my window to be kind of the same as that one there. Oh, sorry. This is what I see here. So the window that we have is from 666 is all of these here. So let's see what we have. So I can go here to the little wrench if I remember how to do that. And let's just go from -6 to +6. That's a pretty good step there. And let's go from -6 to +6. So I'm just using the window that was provided in the question here. So you can see it goes from 6 to 6 in all the different directions there. So here we have a y-intercept of 5, which is good. We have an x-intercept of -1. So I'm just going to move this to the other screen so I can just write this out. Sorry, my program's a little slow. Let's put this in red here. Okay. So what did I say? I said -1. It's my x-intercept. +5. My y-intercept. In Desmos, if you want to look at some of the table, you can. So when you're here, and you're like, okay, I want some extra data points here that maybe I can plot that might be useful for me. I can hit this little gear button here and hit the table button right after. So let's convert to table. So there's a table. You know that most of these data points are beyond what we have, like 110. That's too far. The ones we've plotted here are already here. I don't know what else we could do here. Maybe if I put a x value of -0.5. Yeah, it's 6.6-ish. So at this point, we'll just do a little. Just 1 second. Anyway, sorry about that. Okay, so let's pull this out. So I'm just going to do a little sketch of what this looks like here. There's a little bit of a kink in it like that. It looks pretty bad. Like if I were to make you sketch this, I'd give you a bit more appropriate scale to do this. But we can definitely answer this question now. How many x-intercepts are there? Well, there are 1. Crosses once. Remember, this is a cubic graph. The degree of this one is 3, because that's the highest exponent. And if it's a degree of 3, like I think I mentioned this before in one of the videos, if it's an odd degree, it has to cross the x-axis once. It just has to. Because the degree of 3, it's going to have 1, but it could have 2, it could have 3 x-intercepts, and have a maximum of 3. In this case, this graph just has the 1. Y-intercept, remember the y-intercept is the constant value. This one here, this is the constant. I'm just going to label things here, constant. Remember, this is the y-intercept. So if the constant is 5, the y-intercept is 5. The domain, remember we had all these? The domain of all of these are just XER. The range, because this is an odd graph again, so I'm just going to mention, we're going to put down YER first, but because it's odd. Now remember, if it's a quadratic graph, it has a bottom or a top to it where the vertex is, so there's some graph that's not up there or below it. So what do we have here? Number of turning points. There are 0 turning points to this one. Notice that this graph is continually going upwards. It never actually goes back down. Okay. N behaviors, remember this one's where does it start? So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this one starts in quadrant 3 and ends in quadrant 1. There you go. Let's see what else we have here. Got a graph represents, oh, what kind of graph is this? This is a cubic polynomial function because of the degree of 3, right? Since you have a degree of 3 over here, this is definitely a cubic graph. All right, so based on the shape of this graph here, because it's going, because the end's going in different directions, it has multiple turning points here. It's definitely not a quadratic. Right? This one actually has 2 turning points. It doesn't ask that question, but there are 2 turning points. And it has 1, 2, 3 x-intercepts here. So we call those 3 zeros. So, yeah. So at least what I'm counting here. So when I print this off, that's what I'm looking at. Cool. What are the possible graphs for this one here? This one's kind of a weird abstract one. They're just talking about in the form. This is the linear form as y is equal to mx plus b. They're saying that b is a negative number. That's what that means. And a, because it's greater than 0, is a positive number. If b is a negative number, that's this piece. That's my constant. Remember, the constant is the y-intercept. So if it's negative, that means I'm going to have a negative y-intercept. So it could be one of these two, not this one or this one, because this would be a b that is greater than 0. And this would be a b that is greater than 0. So I'm just going to put the exclamation y across those off. So my a here is positive. And remember what we said about odd graphs that have positive leading coefficient. That's my leading coefficient. Remember, that's this. If it's positive, it's going upwards from left to right. If it's negative, it's going downwards from left to right. So this is going to be not this one, because this would have an a that's less than 0. So it has to be C. I just want to go up to like these ones up here, just mention like, you notice that this leading coefficient is positive here, positive 3. That's in front of the highest degree. Don't worry about the 2. It's whatever's in front of the highest degree. And you notice that that graph is going upwards from left to right. Same thing with this. This graph is going upwards from left to right. You look at one endpoint to the other endpoint, it's going upwards. So I can say that the leading coefficient of that graph is also positive. Okay. So you can see a couple in here, like these are, like these both have positive leading coefficients. This has a negative, these two have negative leading coefficients. That's beside the point. Really, if they ever ask this kind of question here, just pull out your graphing calculator, just plug it in there, try to match it up. Seems pretty easy. So just type in exactly the way it is, x plus 1 bracket squared bracket x minus 2 bracket. I graph that. Mine is backwards, so it's not quite the same here. So it's not going to be A. It's actually, because my thing is backwards, it's actually C. It's this graph right here. Okay. Here, Pauline throws a ball in the air. What's the maximum height of the ball? So I'm just going to pull up my graphing calculator. I'm going to type in this equation. You notice I kind of just skimmed by what was actually in the question because some of it's kind of useless. So what are we looking for? Maximum height, and what's the domain and range of this question? Because this question is a real world question. My domain and range is not just going to be XCR and everything below a certain point, because this one's quadratic, so there's a maximum point here. If you use Desmos, you just click the graph. There's a little gray dot at the top there. I'm going to just highlight a couple of points that we might need. Like, here's my y-intercept. Here's where the x-intercept. You can think of it, this is logically what this question is. You throw a ball up in the air, and it lands on the ground down here. So this negative portion of the graph doesn't really count for anything. And the negative portion on that side over there is negative time. So that doesn't really mean anything in this question as well. So I have my points here. I'm just going to move that over here so I can read them off and write them down at the same time. So what's the maximum height? Now, the y value, I believe, is the height. So you look at the maximum height, you just pull out the y value. 6 point, doesn't specify, so let's go with 1 decimal place here. 6.3, it's in meters. Doesn't matter how you spell meters, but that's fine. And the domain. Okay, so the domain is x, and it's going to start at times 0, because x is seconds, and it's going to run till when it hits the ground. And it hits the ground at 1.4 seconds, XER. We put the XER, remember, for continuous graphs, so graphs that are nice, smooth, there's no holes in the graph or anything. Range, so the range is from the top to the bottom of the graph. So the range is going to go from 0 to the top. You always go from the lower number to the higher number, sorry. So it's the bottom of the graph to the top of the graph. And we have the 6.3 meters at the top. There we go. Pretty good. How many turning points in this graph? This is pretty easy. So here's a graph. Remember, a turning point is when it goes from up to down and down back to up. So this graph has 2 turning points. It's cubic, so the maximum number could be 2, but it could also be 0, right? Like the very first one had 0 turning points to it. Determine the slope of this regression. Okay, so I am going to pull up my graphing calculator here. Sign in. I have to sign in, but you just go to the link that I gave you to find that regression. So polynomial regressions here. Looking pretty good. I'm going to open that up. I'm just going to get rid of all of this. Maybe you could turn off these regressions. Do you want to pick the best ones, right? So you want the one with the r squared value that is closest to 1. In this case, they're just telling you it's linear. Yeah, they just say it's linear in this one. I'm going to put that negative 0.1, sorry. So it makes it look nicer. Okay, so I got my graph in there. Look at some of these r squared values. Actually, it looks like my cubic stuff is more what it should be, but they want this to be a linear regression, so let's just stick with that. Maybe you can zoom out by holding down Shift and stuff. I'm just going to make this look a little bit nicer. Yeah, it looks pretty good. Some of these dots are a little bit far off. I'm just going to double check those. Yeah, looks pretty good. Okay, so once I got my regression, I can determine the equation of this regression. It's down here at the bottom, right? Ax plus b, here's my a, here's my b. So I'm going to write that equation down. I'm just going to go to it says to the nearest 100, so that's 2 decimal places. So 0.09x, I'm going to round that up, minus, because it says plus b, but the b is negative, so 3.42. Okay, so remember that this represents the y-intercept, and this represents the slope of a linear line, right? So this is my nice linear line, y is equal to mx plus b. If you look at that, you see that same number is right here, right? So my y-intercept is the same. The slope is the other number, the a value here. Okay, so my slope, right there. Awesome. What's the degree of this polynomial? This is a pretty easy question. 5, right? The highest number is your degree, the highest exponent, as long as it's polynomial. Here it says use regression. It doesn't specify what kind of regression, so we are going to determine that by using the r squareds here. So -5, -3, -2, 1, 3, 4, and 7. Okay, so I got my values there. 1.8, 1.1, 0.9, 1.5, 2.4, 3.8, and 8.6. Okay. So I'm going to look over here at my r squared value. So I got 0.9987, 9932, and 6. So it's definitely not a linear line. Okay, so let's get rid of that. So it's definitely not going to be a linear line. So it could either be a quadratic or a cubic graph, right? Either one of those two. What are we trying to find anyway? What x is 10? So let's, because the cubic one seems to match the best, let's take off. Sometimes they just tell you which one it is. I'm going to say that this one's be cubic because it has the better one. And then I just want to find out when x is 10. So I could just go along this graph until I find 10. Oh, just a little bit further up here. Right there. Now remember, you could also just place, I want x to be 10, so you say x is equal to 10. It puts a line, a vertical line there for you. You can just click on the dot now. So the y value is 16.67 to the nearest tenth. So 16.7. Now I just want to double check. If I used quadratic here, would I get approximately the same number? Let's see. Just everything over there. Okay. What would I get if I used quadratic? Ooh, I would get 14.9. So if I don't specify which quadratic you use or which regression you use, pick the best one. So the cubic one was the better one because it did match the data nicer. But if I specify, say this was a quadratic, this would be the answer. But I didn't specify that. So 16.7 using cubic for this one. I just seem to have a better regression. Determine the equation of this one. So this one here, you can actually do this one without graphing it. It's an odd graph. So it is going to be, just 1 second. Yeah, so we can figure out what this graph is just by analyzing what it is. So we have this downward slope here, so that gives you a negative leading coefficient because of this here. So this downward slope here means a negative leading coefficient, okay? It's also, because it starts off in one quadrant, ends down here, this doesn't go back on itself, so it's not a quadratic. So it has an odd degree, so it's not going to be A or B because those are quadratic. It's not going to be D because the leading coefficient is positive, so it has to be C. And then you can just verify that, oh, my constant term, this is the constant term. Constant term has to be equal to 1. So you go through and you say, okay, it can't be A or D, so it has to either be B or C, but we already ruled out B. It's a pretty easy question. Here they give you a question. They give you a time, so they want you to just find the distance. So you're just putting in this number that they give you into the equation. It says represents in time, the first hour. Remember, an hour is 60 minutes in length. So I'm not just going to put a 1 in there. I'm going to put 60 into the equation. So 153.8 times 60 plus 86. So I'm going to get, if I did that, I get 9,314 meters. Okay, because D is going to be represented in meters. Okay, these are all kilometers here, but remember a kilometer is 1,000 meters. So this would be 9.3. So you can move this decimal 3 times. Land right there. So 9.314 kilometers. So it would be D. Determine the equation of regression here. Okay, so let's look at this one. I'll plug this in my calculator again. So I'm just going to go here, hit delete a bunch of times. Okay, 2, 5, 8. Oops, 2, 5, 8, 10, 12, 14, 18, and 20. Okay. Sometimes I don't like having these extra lines in the bottom. Let's get rid of this again. 135, 120, 105, 102, 92, 85, 78, 64. Okay. You look at all these equations they're asking for, they're all linear. Yeah, the best one actually is in this case, it is cubic again, but I'm going to just, because they want the linear equation, I'm going to put the linear one here. Oh, I have to get rid of this other line that I have here, so let's just get rid of that. Okay, that makes more sense. And since I don't see the data, you look at the y values. The y values are a little bit larger, so you can scroll up or just change it until you see the data. And there's my data. It does actually look pretty linear. My equation, my a value of the ax is negative 3.9. So the only one there matches is a in this case. There you go. The average retail price from some point to another point here is this here, based on this equation, it's a weird cubic equation, where P is the price and Y is the number of years after 1997. What's the average price of gas at 2002? So we got to figure out how many years after 1997 is 2002. So one way to do that is just subtract the two numbers. Okay. So if I subtract my two numbers, 2002 minus 1979, yeah. So this is 23 years after the time. Okay. So if it's 23 years, I'm going to put 23 wherever these y's are in this equation, or I can graph it and then find where it's equal to that. So I'm going to do the graphing one. Okay, let me just put a new graph here. Back to Desmos. I'm going to type this in. I'm not going to use y's like they are. That's just a kind of confusion there. So I'm just going to go, just type the equation in. Oh, sorry, I'm not going to use y. I'm going to use x because most calculators can't do it that way. X squared plus 4.830x plus 25.720. Okay, so got this graph here. You can't really see it too well. There it is right there. Pretty good. And I want to know at 23, so when y is equal to 23, which is in our case, which is x is equal to 23, so that is equal to 23 at 71.7. Up there, it's D in the situation. Now again, you could just do that by plugging in 23 into this equation here. So I'll write this whole thing out here. I run out of space. There you go. If you type all that in your calculator, you should get 71.7. Okay. What do we have now? Determine the quadratic regression of this data. And so let's find out the quadratic regression. So I'll go back to my Desmos here, back to my regression. I'm going to leave the other one open just in case. 10, 11, 12, 13, 14, 15, 16, 17. Desmos is pretty smart. Actually just fills it in for you. Went too far though. Everything looks like it matched up there. Okay, quadratic. Let's do the quadratic one here. Oops. Turn that on. Oh yeah, my A is a positive 4.2. My B is a negative 107. So let's go back to my question here. So it has to be It's got to be A or B because I have a positive A value. They all have a negative 107, so that doesn't help me. But my C value is 803.5. 803.5. Let's go back to the question. 803.5. That's A. Right? Because these ones match, but we already crossed this one off because the A value is wrong. Cool. Okay, so we have a few more here. We have 2 more questions, sorry. Am I good? Oh yeah, so I want to graph this one out. Pull this out. So remember, when you're graphing these, you can't use other variables. So you got to use x's. So rather than a d, I'm going to put a squared or x squared there. I'm going to go minus 20.7x minus 26.28. Awesome. Okay, so we've got an equation here where h, the y value is going to be my height, and x, or in this case d, is the horizontal distance. So how far is the shot put traveled when it finally hits the ground? So let's see. Here's my graph. Let's just zoom in a little bit, make it look nicer. Pretty good. So it gets thrown at a height. So remember that if this is t on the bottom, or my horizontal distance, this is my initial distance. So it's 1.61 meters off the ground. So that's probably just him throwing it from his ear level there, pushing it out, goes up, hits a max height of 6.4, and then it hits the ground over here. This, remember, the y-axis is the height. So if my y is 0, then this other number, the x value, is 21.9. That's my horizontal distance. So what does that say? 20.9. Was it 20.9 or 21.9? Oops. Oh, 21.9, my bad. 21.9. And then meters, yeah, this was in meters, yeah. Horizontal distance in meters. Cool. Looks pretty good. And the last one here, we're just going to do regression. So I'll pull my regression calculator here. Just type these numbers in. Delete, 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 delete. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's awesome. And 12.4, 30.3, 41.1. And it says in the question we're going to do a cubic regression, so that's good to know. So they're just telling us what to do. Even though one might be better than the other, sometimes they just tell us. Oh, I missed something. 1, 2, 3, 4. Oh, there's no 5. Oops. I have to get rid of 5 there. Okay. It's weird that there's no 5. I think they're going to ask us for what is at x is equal to 5. You can see that's missing there. So we're doing a cubic one. Turn cubic on. I'm going to turn off the square. So this, yeah, looks pretty good. The cubic one is the better one of all 3 of those. There's the data. So we can grab the axes and stretch it out, make it look a little bit better. We're looking for x is equal to 5. So what I'm going to do, I'm going to put that line in there. So x is equal to 5. You put a little vertical line there, and you notice that my y value is 61.1. 1 decimal place here. Everything else is 1 decimal place, so let's just use that. So what did I say it was? 61.1. 61.1. The regression here, the equation, is going to be a bit more laborious to write out here, but you're just going to use all these A, B, C, Ds that I have here. Let's just all use 1 decimal place for all those. So my A value, I just put it on the other screen so I can write this out. A value is 0.4x cubed. And then my b is negative, but it says plus bx squared, so it's negative 4.9x squared. Then it says plus c, and my c is positive 30.3x, and this is plus d. My d is a negative number. And I'm going to round that. There you go. Looks pretty good. That's it. hopefully that helped out. Hopefully we got most of those done already before I started this, and then you got 100%. Maybe you want to come to this video just to see how I did a very specific question. It's up to you. Okay, I'll see you in the next video. Bye.